angle 1 and 4 form a linear pair. Find that. If you need some time, maybe pause the video, but look for what type of conclusion you can make. Well, that satisfies the conditions for the supplement theorem. So use your law of attachment that says if you satisfy those conditions, then go ahead and make the conclusion. So what conclusion does the supplement theorem make about angles that form a linear pair? Well, it says that they're supplementary, so we're going to make that conclusion. We know that by the conclusion of the supplement theorem, angle 1 and angle 4 are supplementary. Maybe that's not where you wanted to go right away, but that's what that conclusion makes. That's as far as we can go. Actually, that second piece, we already have an equation, so I don't know if I'm going to change that. But then one thing leads to the next. Using this idea of the law of syllogism, where can you go to from there? So you have, they are a linear pair. Now we know they're supplementary. Then what do we know? Find out if we can go further with this. Find out where angle 1 and angle 4 are supplementary. Where angles are supplementary, where are those conditions satisfied? What theorem, what definition? If you need to pause again to look for it, that's fine. But you should find that under the definition of supplementary angles. And if angles are supplementary, that definition, by definition of what supplementary angles are, we're able to conclude that their measures add up to 180. Well, we already have something else that adds up to 180. So we have two separate things that add up to 180. We're going to use replacement rule and replace one of those 180s. And I don't care which one you replace. If you want to just rewrite this one, maybe I will this time. Just write the one that I just ended up with. Measure of angle 1 plus measure of angle 4 equals, well, we're going to replace 180 because 180 is not only equal to those two, but it's equal to another sum from our given measure of angle 1 plus measure of angle 3. And if we'd done it the other way, it'd still work. Actually, it would have been a step quicker, but that's okay. It should still get us to where we need to go. Replaced 180 with that other sum. What do you notice about that equation? We're trying to prove 4 and 3 are congruent. Well, that means everything else in this relationship with 4 and 3 in it should kind of disappear, which, see how they're the same on each side? You have a 1 and a 1. They will. You can subtract the 1, the measure of angle 1, from both sides. You don't necessarily have to show that, but I will just so you can follow it easier. We're not doing an algebraic proof. You don't have to show all your algebra. We can just show what we would get. Measure of angle 4 would equal measure of angle 3 after you subtract it from both sides of the equation. So now maybe pause again if you need to look for that property. What says you can add or subtract something from both sides of that equal sign? Additive property of equality, APE. Really close. There's only two things I need to change to get exactly what we're trying to prove up there at the top. I need to switch the order, and I need to change them to congruent, and it doesn't matter what order you do it in. If we switch the order first, that would be symmetric property of equality because it's an equal sign. If we'd waited to the end, it would have been symmetric property of congruency. But I'll switch the order first, symmetric property of equality, and then I'll change it to congruent. Those two things needed to be done. We could have done in whatever order we wanted to. Would have changed that symmetric property a little bit, but ending up with the same thing. Definition of congruent angles. If you already know the measures of angles are equal, congruent means that they'd be congruent. If all the measures of something are equal, then they're congruent, and with an angle you only have one measure. So you've shown all the measures. Well, then you can say it's congruent by the definition of congruency and what congruency means.